Let's look at trigonometry ratios. What are they and how do we use them? So trigonometry ratios are ratios that we can use to find missing sides and angles in right triangles that are not special. There are special right triangles like a 30, 60, 90 or a 45, 45, 90, and they have some special properties. But trig ratios come in handy when we have a right triangle that maybe has a 90, maybe a 26 here, and we would have its complement up here. So let's look at a right triangle that we would use this on. This would be an example of a right triangle that we might use it on. This is called the theta symbol, and we just label that as our reference angle that we're using. So if this is my theta angle or my reference angle, the first thing you have to do is be able to identify your three sides. You're always going to label hypotenuse, opposite, and adjacent. So what I like to do is first identify my hypotenuse. The hypotenuse is pretty easy. You should be able to remember where that is from the Pythagorean theorem when you studied it. It's always directly across from your right angle, and it's always your longest side of your right triangle. So that one's pretty easy. I always label that hypotenuse, and then I actually put my finger on my reference angle or my theta angle, and to figure out which side is your opposite, just follow your finger directly across the triangle, and the side that is directly opposite your theta angle is your opposite side. It is opposite of your theta or reference angle. Now the adjacent side is always the side that's left over. Adjacent means right next to. It's right next to your theta angle, and it helps create that angle. It's one of the sides of the angle, the non-hypotenuse side. So the first thing we're always going to do is we're going to label our sides: opposite, adjacent, and hypotenuse. Okay, so the three trig ratios, the names of them are sine, cosine, and tangent. Remember, a ratio is a comparison of two numbers, in our case, two of our side measurements. Now, these you're going to have to memorize. To set up our sine ratio, we're going to put the length of our opposite side over our hypotenuse side. Opposite over hypotenuse. Cosine is going to be our adjacent side over our hypotenuse, and tangent is going to be our opposite over adjacent. I always like to say tangent's a little bit different than the other two because it doesn't use the hypotenuse. You might have heard this term down here. It's just a memorization term so you can remember those three ratios. SOHCAHTOA. So for sine equals opposite over hypotenuse. Ca for cosine equals adjacent over hypotenuse. And TOA for tangent equals opposite over adjacent. So if I were doing a quiz or a test or anything that involves trig ratios, I would always write at the top of my paper SOHCAHTOA so that I could remember how to set those up. Okay, so let's learn how to just identify and set up some of the sides of our right triangle. Okay, so it says identify the side that is opposite of Z. So we have a right triangle here, and the right angle would be here. And we're using Z as our reference angle. So we're going to put our finger on Z, and I want the side opposite it, so I'm going to follow straight across my triangle to XY. XY is my opposite side. So I'm going to put side XY. And then it says identify the side that is adjacent to Z. Well, if I look at this triangle, well, this is my opposite side. I'm going to label that. I know that the side directly across from my right angle is my hypotenuse side. So the only side left is XZ, and that is my adjacent side because it's right next to and helps make up my reference angle of Z. So XZ is going to be my adjacent side. Okay, let's look at another one. So it says identify the side that is opposite of angle H. So angle H is our reference angle. So we're going to put our finger on H, and we're going to go directly across from H and find IU. So side IU is our opposite. And of course, our hypotenuse is across from our right angle, which is right here. So that's our hypotenuse. And the only side left is IH. So let's look at our reference angle. Remember, adjacent means right next to. So IH is right next to and helps create that reference angle. So IH is my adjacent side. So that's the first thing that you have to be able to do is identify which side is opposite, adjacent, and hypotenuse. Let's see, let's do. All right, now let's look at some right triangles with some side measurements, and let's practice writing those ratios. So if I want the sine of C, I'm going to circle C. That's my reference angle. They could have told me A, but they told me C, so we're going to go from there. So if I want sine, remember, SOHCAHTOA, SOHCAHTOA. Sine is opposite over hypotenuse. So if I look at my triangle, the first thing I'm going to do is circle my reference angle, and I'm going to label my sides. Directly across is my opposite. Adjacent would be my 20 side, or my CB side. And the side across from my right angle is going to be my hypotenuse. Okay, label your three sides, and then look at the sides that would make up sine. Opposite, hypotenuse. Opposite is 21, and hypotenuse is 29. So sine of C is going to be 21 over 29. It also says to express your answer as a fraction in the lowest terms. So we're not going to turn this into a decimal, although we could, but we're just going to leave it as a fraction, and that can't be simplified, so we're going to leave it just like that. All right, let's try another one. So on this one, we're going to find the sine of C as well. So I'm going to circle my reference angle because we're looking from C. I'm going to label my sides. Across is opposite. Across from the right angle is my hypotenuse. And then that leaves the only side left, which is adjacent to my angle. Right there. Okay, so sine, remember, we just learned sine is opposite over hypotenuse. So that's my opposite side, which is 30, over my hypotenuse, which is 50. And that can be simplified. 30 over 50, divide both of them by 10, and you get 3/5. Okay, so let's try some with cosine. So cosine, so it's going to asking us to find the cosine of angle C. So circle C, that's your reference angle. And the first thing we're going to do is label our sides just like we did up here. Across from C is opposite. Across from the right angle is our hypotenuse. And adjacent to C and helping make up C is our last leg right there. All right, so cosine, if I remember up here at the top, cosine is adjacent over hypotenuse. Okay, so adjacent is going to be my 36, it looks like, and hypotenuse is 39. So my cosine of C is going to be 36 over 39, my adjacent side over my hypotenuse, and I need to be able to simplify those. So 36 divided by 3 would be 12, and 39 divided by 3 would be 13, and there is my ratio in simplest form. Okay, so let's try one more cosine. We're going to do the same thing here. Cosine of C, circle our reference angle of C, that's a C if you can see it, and label your sides. Across from C is my opposite side. Across from my right angle is my hypotenuse. And adjacent to my angle is my adjacent side. Okay, Cosine is adjacent over hypotenuse again, adjacent over hypotenuse. So that would be 8 over 17. And since that can't be simplified, I'm going to leave it just like that, 8 over 17. Now let's look at some where we're going to find the tangent. So the tangent of A, all right, first thing we always do, circle our reference angle and label our sides. From A, straight across is opposite. Across from the right angle is my hypotenuse. And my only side left, which is right next to A, is my adjacent side. Okay, tangent, if you remember from up here, it's opposite over adjacent. Tangent is opposite over adjacent. Does not use the hypotenuse. Okay, so my opposite side is 12, my adjacent side is 35. So 12 over 35, and it looks like both of those are divisible by 3. No, they're not. So I believe that that's in simplest form. Yeah, that's not divisible by 3. Okay, now let's try one more with tangent. So it says tangent of x. So x is right here. That's our reference angle. Now, tangent of x, let's see, let's label our sides. Across is our opposite. Across from right angle is our hypotenuse. And the only side left, which is adjacent to my x, is my adjacent side. And of course, tangent, we just practiced, was opposite over adjacent. So that would be 38 over 20, or no, 36 over 27. And 36 over 27, that can be simplified. 36 divided by 9 is 4, and 27 divided by 9 is 3. So 4/3. Okay, let's look at a couple more examples. So on this one, we're going to find the sine, cosine, and tangent of A, and then we're going to find the sine, cosine, and tangent of B. So we're going to use two different angles on these. Now, if I'm doing A, remember sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Okay, so let's just write those down. Okay, so from A, let's see, I'm going to use two different colors. If I use A as my reference, then directly across from A is 15, and my hypotenuse is 17. So if I want the sine of A, I'm going to put 15 over 17. And that can't be simplified, so I'm going to leave it like that. If I want cosine, then I want the adjacent side to A, which is 8 over 17. And if I want tangent, I'm going to put the opposite side, which is 15, over the adjacent side, which is 8. So 15 over 8. Now let's look at B, angle B. So angle B is up here. And if I use B as my reference, now watch what happens. Now 15 is no longer my opposite side because opposite of B is 8. And adjacent to B is 15. So the 15 side and the 8 side actually swap. So if I look at A, 15 is opposite. But if I look at B, 8 is opposite. And of course the hypotenuse never changes. It's always directly across from the right angle. So if I look at B and I want sine, and remember sine is opposite over hypotenuse. What is opposite of B? 8. What is the hypotenuse? 17. So now the sine of B is 8 over 17. The cosine of B is going to be adjacent over hypotenuse. So the cosine is going to be the side that's adjacent to B, so that would be my 15, and my hypotenuse is still 17. So the cosine is 15 over 17. And then the tangent, so tangent is opposite over adjacent. Okay, so from B, the opposite side is 8 and the adjacent side is 15, so my tangent is going to be 8 over 15. Now, it asks us to figure out or look at how do your answers in 11 through 13, these top three, compare to those in 14 through 16. So if I look at them, you should be able to see some patterns here. If I look at the sine of A, which was 15 over 17, that appears down here again, but now 15 over 17 is the cosine of B. So those are equal. So the cosine of A, or the cosine of B, is the same thing as the sine of A. And then you should also note that 8 over 17 appears again. It appears down here. And the cosine of A is actually the sine of B. So they appear again. Now let's look at the tangents of the two that I have left. I have 15 over 8 is the tangent of A, but the tangent of B is actually the reciprocal of that, which is 8 over 15. So make a note that the tangent of A is actually the reciprocal of the tangent of B. And we'll get into those a little bit more in a later video, but there definitely are some patterns between the two angles in a right triangle that are not the right angle.